Hello and welcome to Empowered Learning. This video will be the final video in the video series for finding zeros of polynomials of high degree. And so what these last examples are going to do here is actually exercise what we know about the irrational and complex conjugate pairs theorem that we learned in part 1. And so if you need to know how to do the whole process of finding zeros of polynomials of high degree and factoring them down and using synthetic division, then you want to search for the same video with the same title. Just do part 1 and you'll find it, and you should see all of them together. But if you just need to know how to do this part, then of course this video is perfect for you. So our goal here is to use the irrational and the complex conjugate pairs theorem for polynomials to be able to write out polynomials in factored form, and we also want to multiply them out. And so I'm doing the painful process of multiplying them out to get your polynomials in canonical form, or the form that you normally see polynomials in when they're not factored out. I'm doing that because I know for some of you, when you have your homework assignments to do, some of your homework assignments ask you to actually multiply these polynomials out. So if you kind of get lost in the sauce, as I like to say, in trying to do all that, hopefully this video will help you out. All right, so first thing, let's look at this first example here. And we notice that we have a polynomial and it's of degree 5. So what that's telling us is that we have 5 zeros that we have to account for. We see here that we have 3 of the 5 zeros, okay? Now we know that the irrational conjugate pairs theorem for zeros tells us that if I have an irrational number like this one, and I know it's irrational because square root of 5 cannot be expressed as a fraction, then I also know that an additional zero that I have is minus square root of 5. And I know that because the irrational conjugate pairs theorem tells us that if I have an irrational number that is a zero for a polynomial, then I know its conjugate is also going to be that. And of course, I could express square root of 5 as 0 plus square root of 5. And of course, its conjugate would be 0 minus square root of 5. And simply put, that would just be square root of 5 and minus square root of 5. So now that we know that we have this zero accounted for our irrational zero square root of 5, we also know that for the complex conjugate pairs theorem, we have this other zero, positive 4i. Okay? And so we have all 5 zeros accounted for, so we could write our polynomial in factored form to look like this. So our rational zero of negative 1/2 would translate to a factor of x plus 1/2. Our zero of square root of 5 would be x minus square root of 5. And of course, I'll skip over here and do this one. This would be x plus square root of 5. And of course, we get that because x minus a minus square root of 5 would be the same as x plus square root of 5. So that's where that comes from. Of course, our zero here at negative 4i, that would be x plus 4i for the same reasons as we got x plus square root of 5 here. And then our last zero here would be x minus 4i. And so for those of you that only need to be able to write out these polynomials in factored form like this, this is where you stop. For those of you that have to multiply onward and actually express this in canonical form, I'm actually going to do that now. So before we do that, there's a few things that I want to discuss. And so I'm going to break away to do that, and then we'll come back here and actually finish out multiplying this polynomial. So one of the things I want to bring back to your remembrance here is what happens whenever we multiply two complex numbers that are conjugates of each other together. Okay, so if we were to FOIL this out, what we see this would be a squared minus abi plus abi minus b squared I squared. Okay, so we're just doing first, outside, inside, and last of the FOIL method. Notice that these two terms here cancel to 0. And also remember from learning about complex numbers that I squared is equal to -1. So all that you see here, that would be a -1. And of course, a negative times a negative would give you a positive here. And then of course, we have a squared. So we see that anytime we multiply a complex number times its conjugate, we end up getting a squared plus b squared. And since both a and b coefficients are real numbers, this actually ends up being a real number. Okay. Now, how this helps us and what we need to do is that anytime we multiply a complex number times the conjugate of itself, we know what that form is going to end up looking like. And we're going to exploit this to be able to help us to multiply our polynomial in such a way to where it just cuts down on the amount of steps that we have to do. Now, similarly, if you remember that we have a minus b times a plus b, if we did the FOIL method for that, where a and b are real numbers, we'll have a squared plus ab minus ab, and then minus b squared. And of course, these two middle terms would cancel to 0, and we'll have a squared minus b squared there. So we're also going to use this relationship to our advantage as well. So now that we're back here, I can rewrite what I have this way. So with the x minus square root of 5 and x plus square root of 5, that's going to go along with my situation here, where I know that a minus b times a plus b is just going to be a squared minus b squared. So what that looks like for me here is this will just be x squared minus square root of 5 squared. Okay. And for the x plus 4i times the x minus 4i, you'll see that this follows what happens whenever I multiply a complex number or complex expression times its conjugate. Of course, in this case, this will end up being x squared plus 4 squared. Okay. So from here, I know that this is just going to be x squared minus 5, and this would be x squared plus 16. And then I'm going to take these last two and actually FOIL those together, and that would be x raised to the 4 plus 16x squared minus 5x squared minus 80. And of course, from there, we would simplify the first two terms, like terms. And then from here, we would just multiply the x plus 1/2 times the x to the 4 plus 11x times minus 80. Yeah. So we'll run through and multiply everything by x first. So x times x to the 4th is x to the 5th plus the next is 11x squared minus 80x. And then we'll run through again and multiply everything by 1/2. So this will be plus 1/2 x to the 4th plus 11/2 x squared plus 1/2 times a negative 80, which is negative 40. And so here, this is the answer, but we're just going to rearrange everything to where we go in descending order with the exponents. So I have x to the 5th, and then this will be plus 1/2 x to the 4th, plus 11x cubed, then plus 11 over 2x squared, minus 80x, and then this will be minus 40. And so this is what our answer would be if we had to write out everything in the traditional canonical form of what this polynomial f of x should be. So this would just be f of x is equal to that, and this would be our answer for that. All right, let's move on to our next example. So for our next example, sort of the same thing here. Well, we see we have 3 rational zeros, and we have 1 complex zero. And again, the degree of our polynomial is 5. We have 4 zeros accounted for. So what we need is what the additional zero would be. And of course, that additional zero, according to the complex conjugate pairs theorem, would just be 1 plus I. And so if we were to write out what this polynomial would be in factored form, it would be x plus 2, because 0 being negative 2 means that x plus 2 is its factor, times x minus 3, because a 0 of positive 3 means that x minus 3 is its factor. Same thing for x minus 4. And then to deal with our complex conjugates, here we know we have x minus 1 minus I. Let's see if I can get that to come out right. And then I have x minus 1 plus I. Okay. So in multiplying this, I'm going to wait to multiply this portion. So I'm just going to keep rewriting this until I'm actually done dealing with the complex part. So here what I'm going to do is I'm just going to go ahead and distribute. So this will be x minus 1 plus I. And then this will be x minus 1 minus I. So what I want to do here to make the multiplication a little bit more simple to do, I'm going to group the x minus 1 here and the x minus 1 here together. And so I'm doing that because I know that the x is a real number, or I'm going to treat it as if it's a real number in this case. And I'm going to group that as the real part of this complex expression here. And I'm going to let the plus I be the imaginary part. Same deal here. So if I do that, then I'm looking at this as if it is an a plus bi times a minus bi situation. And we know that a plus bi times a minus bi is just a squared plus b squared. And so that's what I'm going to use to try to simplify what the multiplication of this would be like. So again, I'm just going to carry the rest of this on, and I want to rewrite it in each step so that I don't forget what it is. So whenever I multiply this, this is going to be like my a, and the understood ones right here are going to be like my b's. So this will be x minus 1 quantity squared plus 1 squared. I'll rewrite this again. And then from here, what I'm actually going to do is multiply out what that is. So the x minus 1 squared is just x minus 1 times x minus 1 plus 1. And again, there is a shortcut that you could use to multiply out the x minus 1 squared, but I'm going to do it the long way just in case some of you are not familiar with that. And so if I FOIL this out, this would be x squared minus 2x plus 1 plus another 1. And then from here, this just is x squared minus 2x plus 2. Okay. And so now from here, what we need to do is I'm going to go ahead and multiply these 3 factors in front, and then I'm going to multiply the cubic expression that we'll get here times the quadratic when they're at the very end. So for here, if I multiply these 2 together, I'm going to get x squared minus x minus 6. And of course, that comes from FOILing. And I'm assuming that you know how to do that. And then I'm going to multiply the x squared minus x minus 6 times the x minus 4. So that will be x cubed minus x squared minus 6x. And I'm going to write this sort of in an unconventional way just to make keeping up with what we're doing a little bit more simple. So I'll basically take an x and multiply it times all 3 terms here. I'm going to take the same thing with the negative 4. So negative 4 times x squared is going to be a negative 4x squared. And then negative 4 times negative x is going to be a positive 4x. And then negative 4 times negative 6 will be a positive 24. And I'm going to write it like this so that in my next step, I can just add vertically like how we did in grade school to be able to get what answers I'm supposed to get. So this will give me x cubed minus 5x minus 2x plus 24. And then from here, we can multiply these 2 together. And we got several ways that we can do this. You can do the box method. You can do vertical method, vertical stack method, as I like to call it. But essentially, we're just going to take each one of these terms multiplied by each one of these. And again, I'm going to do this in a stacked, unconventional way so that it's easy for us to add everything up at the end. So I'm going to take everything and multiply by x cubed first. Well, we'll take x cubed and multiply it by all 3 of these terms first. So I have x to the 5th minus 2x to the 4th plus 2x cubed. Then I'm going to repeat the same thing with negative 5x squared. So negative 5x squared times x squared will be a negative 5x to the 4th. And then negative 5x squared times a negative 2x will be a positive 10x cubed. And then do the same thing with 2 here. That will be a negative 10x squared. Next, multiply negative 2x times all of this. So this will give me a negative 2x cubed. And let's get rid of that sign there. So this will be, again, negative 2x times x squared is negative 2x cubed. Negative 2x times negative 2x is positive 4x squared. And negative 2x times a positive 2 is going to be a minus 4x here. Pen starting to drag a bit. And then lastly, we'll take 24 and multiply it times x squared minus 2x plus 2. And This will be plus 24. Seems like my 4's don't want to come out right. So 24x squared minus 48x and plus 48. And of course, we'll take all of this and add it up. So here, this will be plus 48. Negative 4x minus 48x is a negative 52x. And if I add 24 and 4, that's 28 minus 10 gives me a positive 18. So we have positive 18x squared. We have the 2x cubed and a minus 2x cubed. These will reduce to 0 or cancel out to 0. And we have 10x cubed there. Negative 2 plus negative 5 is a minus 7. So this will be minus 7x to the fourth. And then, of course, we have x to the fifth. So this would be our resulting answer for this particular problem. And again, this is only needed if you are taking a course where your instructor or the homework that you're assigned is actually making you multiply all of this out. Okay? All right, so let's look at our last example. So for our last example, again, we have a polynomial of degree 5. And this time we see that we have an irrational 0, we have a complex 0, and we have a rational 0. Since our degree is 5, we have to account for the other two zeros, one of which is going to be the conjugate pair for the irrational. The other one is going to be the conjugate pair for the complex. And so now, if we're going to write what our polynomial should be, this will be x minus 5. Take care of the rational one first. And then to take care of the irrational ones, we'll say this is x minus 2 plus square root of 3. And then x minus 2 minus square root of 3. And then x minus 4 plus I. And then x minus 4 minus I. So again, if you need this in factored form, you could leave it like this and this would be fine. For those of you that have to multiply this out, then of course we're going to work on that now. So we have x minus 5 here. And what I'm going to do is distribute all these so that I can group them kind of like how I did in the previous example to make the multiplication a bit easier to do. So we'll have x minus 2 minus square root of 3, x minus 2 plus square root of 3, x minus 4 minus I, and then x minus 4 plus I. And of course, here we want to group the x minus 2's here and the x minus 4's together here. And we're doing that because we want to look at this is A. We're going to look at this as B. And we want to remember that A minus B times A plus B, in this case, is going to be A squared minus B squared. And of course, here we look at this as A, and that is A. And the understood ones here, this is going to be the BI, that's plus, that's minus. So if I was to multiply these two together, then I know that the result here would be A squared plus B squared. Okay. So noting that, we know that our next step for our polynomial would end up being x minus 5 here. And then this would end up being x minus 2 quantity squared minus square root of 3 squared, which is just going to be 3. But I'll write it like this and simplify it later. And of course here, our a in this case is x plus 4 squared, plus our b is just going to be 1 squared. So here we know that our result will just end up looking like this. So now at this point, it's easy for us to multiply out x minus 2 quantity squared, x minus 4 quantity squared. So I'll just go ahead and write all this business here. This will be x squared minus 4x plus 4. Can't seem to get my 4s to write correctly. That is 4 minus 3. And then here we'll have x squared. 2 times 4 is 2 times negative 4 is 8. And negative 8 times x is a minus 8x. So I'm just doing the shortcut there. And then negative 4 squared is a positive 16. And plus 1. Okay. Yeah, my pen wants to do everything but what I tell it. All right. So x minus 5 here. And then this will be x squared minus 4x plus 1. And then x squared minus 8x plus 17. And so what we'll do is go ahead and multiply the two quadratic terms together, and then finish up by multiplying that times the x minus 5 term. So I'm going to multiply x squared times everything here, and this will be x to the 4th minus 8x cubed plus 17x squared. And I'm going to write it in an untraditional fashion, just kind of like how I did the other one, so that it's easy for me to keep up with everything. So next I'm going to multiply negative 4x times all three of these terms. So I'm going to get a negative 4x cubed, positive 32x squared, and it's going to be a negative 58x. And then multiply 1 by all this, which is just going to give me, I'll just write the 1 here, plus 1x squared minus 8x, and then plus 17. And write it like that. Then we'll go ahead and add everything up. So this will be x raised to the 4 minus 12x cubed, 50x squared, 64x plus 17. Oh, that's 66x. Sorry about that. All right, and so now we finally just multiply x minus 5 times everything. And so first we'll multiply through by x for all of these terms here. So give me x to the fifth minus 12x to the fourth. Plus 50x cubed minus 66x squared plus 17x. And then we'll multiply everything through again by negative 5. So I have negative 5x to the fourth. Then that'll be a positive 60x cubed. Then a minus 250x squared. 350x, no, let's say the third term. Yeah, so the third term is 250. The fourth term, that one's going to be plus, and that one looks like what you got 30. Yeah, can't visually see it that far. So that's going to be what, 33? Yeah, so 330. So that's going to be 330x, and then we have minus 85. And then we just add all that up. That's x to the fifth, minus 17x to the fourth, plus 110x cubed. That's minus 316x squared. Okay. And this is 347x. Then minus 85. And so that is what our polynomial would be if we were to multiply everything out after we have it in our factored form here. Okay. All right. So I know that doing these types of problems are very painful, but again, I'm trying to make sure that I cover all bases depending upon who looks at these videos, just to make sure that if you do need to multiply everything out, then you kind of have a strategy for being able to do that. That's the most efficient way that I know possible. If you don't, then of course you can always just stop right where you've got everything nice and factored out. You can either stop here, or you could stop at this point and everything is pretty much good to go. And, or actually, you could actually stop way up here if you wanted to. Yeah, if you don't necessarily have to multiply these things out. So, but anyway, I hope that this video helps. And let me know if you have any questions.